In problem number 45 of section 4.1, we'll look at the population of a certain city, in which they find that each year, on average, about 6% of the current population moves out and about 3,500 people move in. Now, part A asks us to set up a differential equation that relates the population, call it P of t as a function of t, and the rate of change of the population with respect to time. Now, the rate of change of the population with respect to time is just going to be equal to, well, we know that 6% of the current population is moving out, so we have a negative growth of 0.06 P of t, but then we have 3,500 people moving in, so we have positive growth of 3,500. We say that dp dt equals negative 0.06 P of t plus 3,500 is a differential equation relating these two quantities. In part C, we look for the general solution. Not really sure what happened to part B there. I just mislabeled the problems here, so I'm just going to start over with when I switch over to the new board. Okay. Like everything is fine over there, it's just when I came over here. Right. Now we look for the general solution for the function population for population as a function of t. So remember that we found that dp dt is equal to negative 0.06 p of t plus 3,500. Now, we're going to follow an example that was done earlier in the chapter, and we're going to say that u, define u to be dp dt. Now, that means that du dt is equal to, well, u is equal here to dp dt. So du dt is just going to be equal to negative 0.06 dp dt. And the constant term goes to 0. But since u is just equal to dp dt, this is going to be equal to negative 0.06 u. So now we can solve the differential equation for u, or we can solve the second differential equation, and see that u must equal, let's see, c times e now to the negative 0.06 t. But we also know that u is equal to negative 0.06 p of t plus 3,500. So now we can use these two parts of this equation here to solve for p of t. We have p of t now be equal to c times e to the negative 0.06 t minus 3,500 over negative 0.06, negative 0.06. So here we get the general solution. Now, part C asks, at what time does the population reach 150,000? So we want to know, all right, P of t, let's say P of t1 equals 150,000. what does T1 equal? Well, also given, didn't write it down here, but we're also given that the initial population, so population at time 0, is 60,000 people. So since P of 0 is equal to 60,000, which is also equal to C times now e to the negative 0.06 times 0 is just going to be 1. So C minus 3,500 over negative 0.06. Now, if you work all this out, you'll find that C is actually equal to minus 100. So we know that P of T1 is equal to 150,000, but it's also equal to minus 100 times e to the negative 0.06 T1 minus 3,500 all over negative 0.06. Now, all the minus signs here cancel out, so it would probably be easier just to work with all positive quantities. And now we just use this equation to solve for T1. So if we multiply both sides by 0.06, we get 9,000. And then let's move the 3,500 to the left side. So minus 3,500 equal to 100 e to the negative 0.06 T1. And this reduces down to, we have 5,500 over 100, or just 55, is equal to e to the negative 0.06 T1. Now we can take the natural log of both sides here. Now we have that natural log of 55 is equal to natural log of e to the negative 0.06 T1, which is just negative 0.06 T1. And if we plug this into a calculator, we find that T1 is approximately negative 66.7. Now, it seems like a little bit of a strange answer, negative time, but remember at the beginning of the problem, T is expressed in years since 1990. And what this is saying is that in, well, sometime in 1923, the population was 150,000. And if you graph the function P of T using the value of C as negative 100, you'll find that the graph is actually decreasing. So this does make sense. So if you start out with initial population 60,000 in 1990, population is just going to go down as time goes on. But assuming that the model was true for previous years, sometime if you go back far enough, in this case, if you go back 66.7 years, you find that the model predicts that the population was, in fact, 150,000.